Hi everybody. So this is my third video on the loci of conic sections in Year 12 Further Pure 1. In this video, we're going to find the Cartesian equation for point M, which is the midpoint of the line segment C to P, as P moves along this parabola. We're given that this is the general equation for the tangent at P, and that C lies on the y-axis. So the first thing we need to do is to find the general coordinates for point C. And at C, we know that x equals 0. So we'll substitute the 0 into the general equation for the tangent. So we know that at C, the y value will be at. We'll just divide both sides by this t here. I'll label this on the graph. So now we've got the general coordinates for C and P, we can find the midpoint of M by finding the average x value and the average y value. So at M, the mean x value will add these two together and divide by 2, and this will give us at squared over 2. And the y value at M will be the average of 2at and at, and this will give us 3at over 2. So I'll include each of these on our diagram. So we know then that at M, x is equal to at squared over 2, and y is equal to 3at over 2. So to find our general Cartesian equation, if we make t the subject of this equation, and then substitute that value of t into here, we'll have one equation involving x and y. So 2x will equal at squared. We'll divide both sides by the a and take the square root. So the square root of 2x over a will equal t. And then we'll substitute this into here. So we'll get y is equal to 3a over 2 multiplied by t. And then we'll square every term to cancel out the square root. When we square the 3a over 2, we'll get 9a squared over 4. When we square the square root, this will cancel, and we've got 2x over a. We can cancel out the squared with the a, and we can simplify the 2 and the 4. So we get y squared is equal to 9ax over 2. And this will be the Cartesian equation of a locus of M as P moves around the parabola. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.